Hello everyone, this is Chonga Sojovin and I'm going to be taking you through the MLOps relating it to our project. So let's start right away without wasting time. Let me start with the introduction. So our project is mainly predicting and monitoring the car engine health. So I'm going to discuss to you the way we can apply MLOps to our project in machine learning. So basically, MLOps is a fusion of DevOps automation methodology and practices in MLOps. So it's just a combination of the DevOps automation methodologies and the practices that are done in machine learning. Those are the developing of models, getting data sets, reviewing them, EDA. So all those things combined with DevOps automation methodology is what is known as what? As MLOps. So in the context of our project, which is titled Interpretable Machine Learning Techniques for Car Engine Health Predictive Monitoring, MLOps stands to revolt the way we collaborate and automate tasks within our group. So MLOps is all about the way we are going to collaborate and automate the tasks that we are going to carry out while implementing this project. So these are the some of the trends and the techniques, the MLOps trends and techniques that will influence our project. So the first one is called continuous integration. So continuous integration is a practice that streamlines the development and deployment of a machine learning model. So the development and deployment, the way you develop and deploy your machine learning model, the concept that practices the streamlining of this project is what we call continuous integration. So implementing continuous integration ensures that changes to our machine learning code base are automatically tested, maintaining code quality, and then CD, which is continuous deployment, facilitates automation deployment, making it easy to push updates to your car engine health predictive models. So the continuous deployment will help us to continue introducing new updates to our model in order to develop it or to enhance its activities. So model versioning, this is also another trend and technique that will influence our what? Our project. Implementing robust modeling versioning. So MLOps emphasizes versioning not only for code, but also for models. So each model is supposed to have different versions. So that is what we call model versioning, introducing different versions or different applications of a certain model so that it can work in different versions, but carrying out the same activity. This ensures that you can trace back to specific versions of your interpretable machine learning models. So it's always specifically tracing back to different versions of that model. Another technique is monitoring and logging, leveraging comprehensive monitoring and logging practices. So MLOps encourages continuous monitoring, model performance, and system health. So enhancing the continuous monitoring of the way our model will be performing, that is what we call monitoring and logging. So that will also help in our project in order to monitor the performance of our model. Implementing effective logging mechanism will help track the behavior of the car engine health prediction. So we will keep on tracking the behavior of the way our model is performing, depending on the technique of monitoring and logging. Another technique is automated testing for models. This is self-explanatory. We are adopting testing practices, ensuring that our predictable models undergo testing before deployment. So this is all about continuously and automatically testing our models in order to have clear and reasonable models before we deploy them. So applications of DevOps, DataOps, and we differentiate between the heavy and light MlOps. So DevOps, in the context of our project, DevOps practices will streamline collaboration between our team members involved in developing. I've already explained this. DevOps is always about streamlining the collaboration between members. So some of its implementations, it will use CI and CD, which we have already looked at, which is continuous integration and continuous deployment. Then DataOps focuses on enhancing collaboration and efficiency in data-related processes. So in our project, DataOps practices will be crucial for managing data sets and ensuring their quality. So we are all about managing our data sets and ensuring that they have a good quality. Then this is our workflow, which we chose, which was the heavy workflow, or what they call the heavy MLOps. So we'll start by data collecting and pre-processing the data, which includes just collecting the data from different websites. Then we develop the model. Then we carry out continuous integration, which I've already explained. Then we test the model before deploying it. Then we carry out what we call continuous deployment. Then we start monitoring the model and as we get feedback. So collaboration and documentations, those part of the group members, which involves us collaborating and documenting our entire process as we are developing the model. Then iterative optimization. This is continuously using the feedback in order to enhance the performance of your model. So some of the strategies to handle data poisoning. So data poisoning involves injection of malicious or incorrect machine learning model or incorrect data into your training data set. So this data poisoning involves including false data into your training data set. So the way we can solve this is by employing anomaly detection algorithms during data pre-processing. So these algorithms will be able to find out the incorrect data that was inserted into the training data, hence solving the data poisoning part of the project. Then address data drift. Data drift occurs when the distribution of the incoming data changes over time. So the data that you provided to the model is continuously changing over time. That becomes a problem. So to solve this problem, we're going to implement a monitoring system that tracks the statistical metrics of incoming data, such as mean variance. So we're going to implement a monitoring system that will keep on tracking the incoming data so that we go away with what they call address data drift. Then operationalizing microservices. This involves breaking down your application into smaller independent services. So in our car engine health monitoring project, each interpretable machine learning model can be encapsulated as a microservice. So we are going to be breaking down our application into smaller independent services in order to optimize the performance of our model. So these are some of the roles of continuous integration and continuous delivery, which I've already explained. So continuous delivery is just keeping on to validate the model by keeping on deploying the other versions of the model, while continuous integration is using platforms like Link or GitHub in order to enhance the performance of your model. So the future store In our car engine health predictive monitoring system, a feature store can store relevant features like temperature, engine RPM, sensors, oil pressure, and each and every of the features that we included in our data set. So conclusively, the integration of MLOps into our project focuses on interpretable machine learning techniques for car health predictive monitoring. It holds a significant promise and potential benefit. So by using MLOps, it will direct our project in the right ways so that we can come up with an optimized model. So through the presentation, we have explored essential concepts such as DevOps CID and the use of the future store in our database. So that's it. We meet next time, guys.